Hi, I am Azizah Ainiyyah. My student ID is 220105661, and here I will explain the executive summary. So, this study focused on achieving zero waste in the palm oil industry by converting palm oil mill effluent (POME) into biogas, which is then used to generate electricity through gas engine generators. The core problem lies in the large volume of POME, which contain high BOD and COD, causing environmental pollution if untreated. Our key findings showed that anaerobic digestion effectively transforms POME into biogas. With process control, we can enhance biogas yield and electricity generation, while integrated waste-to-energy system significantly reduce the carbon footprint, supporting Malaysia's sustainability goals.
The palm oil industry in Malaysia plays a vital role in the country's economy, contributing to employment, exports, and national revenue. However, concerns over environmental impacts such as greenhouse gas emission, water pollution, and waste management persist. The industry generates and disposes of palm oil mill effluents, a highly pollutant byproduct which contributes to climate change. To address these issues, Malaysia has implemented policies like the MSPO certification scheme and biogas capture technology. However, these efforts are fragmented and insufficient in providing a comprehensive mitigation strategy. This study aims to develop an integrated mitigation strategy model that combines palm oil mill carbon accounting and a palm oil mill sustainability index to identify environmental weakness, quantify emissions, and optimize mitigation strategies. There are four objectives, which are to quantify and analyze emissions from palm oil mill, to identify and mitigate high-impact pollutant sources, including POME and combustion emissions, to optimize mitigation strategies using mathematical modeling and case studies, to provide a decision-making tool for policymakers and industry stakeholders to enhance sustainability and achieve net zero emissions.
Hello, I'm Jabir, and then this is for the continuous chapter. It's about the process control for zero waste of our company. Especially in here, we will talk about the process control and justification for oil palm industry. In here, we know that the business is rapidly expanding and becoming a significant agriculture industry in Malaysia. And about that, the government also support of the palm oil industry, and it also has contributed to the Malaysian production of palm, which is the disposal or the waste, which has reached at least 44 million tons annually and continues to grow. Meanwhile, the pollution level of palm itself is 100 times higher than that of municipal sewage, which has a high chemical oxygen demand or COD and biochemical oxygen demand or BOD. And also in here we could see the characteristic of the palm itself, where this is the waste from oil palm industry. For the pH itself, we know that the value will be on 4.0 until 5.0, which is the acidic. And for the BOD and the COD itself, it will take about 25,000 until 25,000 for the BOD, and for the COD, it will take about 50,000 until 80,000. For the total solids itself, 40,000 to 50,000 milligram per liter, and for oil and the grease itself, where is the product, we will get just 4,000 until 5,000 milligrams per liter. And this is not specific where the industry will be, but just like the general of information that we could search for it. And as we know, we would like to know how about the process of oil palm industry, and then how can we get the palm to be the clean sign gas, and then it will become the electricity for humanity. So basically, for the general process itself, it comes from EFP, and then it goes to the drying, and then uh, but for the EFP and the pump itself, it's kind of different of the sources. I mean, like for the inlet itself, because the pump is come to the digestion, but for the EFP it will come to drying. And from this one, we will not talk about the EFP, but we will talk about the pump. The pump itself, as you can see on the right side of our schematic or our picture, pump will entering the acidification ponds, and then it will go through the anaerobic ponds, and then it will separate it, time became the biogas and the aerobic ponds. In here, on the biogas section, it will have two separate ways for the gas cleanup, and then they will get the particulate and sulfur, and also the clean sign gas, which we will use it as uh, the source of our gas engine and will become the electricity. Meanwhile, the one that goes through the aerobic ponds will become the maturation ponds and will become the liquid fertilizers. And after we know how about the process of home become to the electricity, and now we would like to talk about uh, the value inside of the when the process it comes. Especially, we will talk about the we know have two items in here, EFB and the POM, but we will like mainly talk about the POM. As you can see on the table, we have the value in here for the POM density is 0.98 and the produced biogas is 25, and for the methane concentration is about 55%. And after that, we could get the gas engine for the power generation efficiency is 32%, and for the total efficiency is almost 84%, and then for the flue gas temperature is 450 degrees Celsius. That's for the value for our process and the control process of our home. And as you can see on the below, we have the chart of two uh, results in here, especially for the gasification temperature and also with the net generated power or the power generated by the gas turbine, and also with the turbine inlet pressure, which is using the unit of megapascal, and it's about between with the power generated. So in here, as we can see, when we increase the temperature, we will get the efficiency or the power generated also will become higher. And as you can see on the below left, when we increase the temperature until 1000 degrees Celsius, we will get around 30 to 40% of energy, which the power generated also like around 6 to 8 megawatts. And on the right side, you could see the turbine inlet pressure and the power generated in here. As we can see, there is no significant change when we have to increase the turbine pressure, and also the about the power itself, there is no significant increase also. Okay, that's all.
Hi, my name is Aliff and my student ID is 20,665, and I'll be presenting on the challenges on process control implementation. So the recovery of palm oil mill effluent for gas generators faces several challenges affecting efficiency, sustainability, and cost. First, POME composition fluctuates due to seasonal changes and processing methods, leading to inconsistent methane content in biogas. Contaminants like hydrogen sulfide can corrode pipelines and engines, requiring costly purification systems. Traditional anaerobic digestion is slow, needing large space and high capital investment. Storage and distribution are also problematic, as biogas has low energy density and high carbon dioxide content, making transportation expensive. Lastly, strict environmental regulations demand cost infrastructure upgrades. Overcoming these challenges require better technology and strategic investment. So now let's move on to the recommendations. To improve the efficiency of sustainability of POME process control, several recommendations can be made. First, optimizing anaerobic digestion using high-rate reactors and co-digestion can enhance methane yield while reducing retention time. Next, improving biogas purification through desulfurization and upgrading it to a biomethane will expand its usability. Real-time monitoring and IoT sensors and automated control systems can further optimize the process. Additionally, exploring alternatives uses like microalgae cultivation can create new value streams. Financial incentives and improved biogas storage infrastructure will also be crucial in supporting large-scale adoption, ultimately promoting a zero-waste palm oil industry.
In conclusion, process control plays a crucial role in optimizing waste-to-energy conversion. Technologies like anaerobic digestion and gasification effectively minimize POME's environmental impact while supporting renewable energy goals. Moving forward, expanding process control system, enhancing biogas recovery, and promoting zero waste initiative will strengthen the industry's alignment with sustainability and net zero target.